This video is on Unit 1, Chapter 3, Systems of Equations, Lesson number 4, Solving Systems, focusing on linear and quadratic functions. So in this lesson, the system is going to have a linear equation and a quadratic equation. Slightly different than what we've done so far in this chapter. So far in this chapter, every single lesson has had equations that are the same. So two equations and two variables, three equations, three variables, and they're all linear. But in this lesson, we're going to have linear and quadratic, and I want to talk to you a second about what can happen in this situation and the types of solutions before we talk about the steps. So if you've got a graph, and you've got a parabola, which is a quadratic, and your line comes through here and it hits that parabola at two spots, what that means is you have two solutions. So we have two solutions. Both of those are going to be ordered pairs, x, y. The other thing that can happen is maybe our line comes through here and I missed the parabola. Maybe the line comes through and it hits just at one point, meaning you have one solution. So one ordered pair, one x, y. The last thing that can happen in this lesson is our parabola and our line might miss each other completely, meaning we have no solution. So when we graph this, which is the method that I'm going to show you today, when we graph this on the graphing calculator, that's what I like to focus in on first is, do I have no solutions? Do I have one solution or do I have two solutions? So let's talk about the steps for this lesson. Because we have not had a chance to review quadratics, I do teach this lesson by using the graphing calculator. We will come back and revisit this later in the semester and talk about how to work this by hand. And I will show you one example of by hand. But again, we have not had a chance to talk about quadratics and reviewing how to solve a quadratic. So I'm just going to focus on the calculator here. So looking at our steps, step number 1 says to solve both equations for y. You want to make y equals mx plus b. Or if it's a quadratic, it's going to be y equals ax squared plus bx plus c. So they both have to be y equals. The second step says to enter one equation in y1 and the other equation in y2, and then you're going to graph those. And you're going to look at the graph on the graphing calculator. And it's at that point that you want to look and decide, how many solutions do I have? Some of the solutions may not actually be on the screen. We'll talk about that in just a second. Step number 3 says to calculate, which is on the calculator, it's second trace the intersection, which is number 5. And then we're going to repeat this process for the second solution if it exists. And then you will need to move the cursor close to the other point before you proceed to step 4. And I will walk you through that very slowly on the graphing calculator here in just a second. Step number 4 says to hit enter 4 times and express your solution as an ordered pair. So looking at example number 1, the directions here say to solve each system of equations using the graphing calculator. So both equations in number 1 are already in y equal. So I'm going to go to my graphing calculator. I'm already on the y equal screen. And I'm going to put the x squared minus 6x plus 7 in y1. The x is right next to alpha, so make sure you're using that. The square is on the left side, kind of close to the 7, minus 6x plus 7. I'm going to hit enter, and I'm going to put in the 2x in y2. Now, when I go to graph this, I don't know what I've done in this calculator before. I don't remember where I've been. So I'm going to hit zoom 6, which is what I like to call home. You can look at this and easily identify, here's a solution right here. Remember that the solution to any system is where the functions hit each other. Sometimes they might hit each other once, twice, or multiple times. So again, the solution is where they hit. So this one's easy to see. The blue parabola, as it extends off the screen, and the red equation, the linear equation, as it extends off the screen, it's obvious to me that these two are going to hit each other off my screen again. So there are two solutions to this. If you want to actually see them, we can zoom out. So to do that, you hit zoom, 3, enter, and you can easily see those two solutions. Now, the step number 3 in your notes says to hit second trace. So second trace is calc. Number 5 is the intersection. And again, we choose number 5 because we're looking for where they hit each other, which is the intersection. So number 5. And then all we're going to do is hit enter, enter, enter. It's 3 times, it's not 4. So enter, enter, enter. Tells me that my intersection, if you look down at the bottom of my screen, one point where they hit each other is 1, 2. So one of my solutions is at 1, 2. Now let's go find the other solution. The other solution, we have to repeat that process. So second trace, number 5. Now, in the notes, it says that you have to move the cursor closer to the other point of intersection. So if I want to know what this intersecting point is, my cursor needs to be close to that. So I'm going to move my cursor to the right so that I get close. And y'all, it just has to be close. It doesn't have to be on it. Enter, enter, enter. My other intersecting point is at 714. So the other answer is 714. Another way to find those answers is to look at your table of ordered pairs. So I'm going to hit second graph. Now we know that the answers already are 1, 2. And if you look here, the way to tell that the answer is that the blue and the red numbers match. So 1, 2 on the blue line and 1, 2 on the red line are the same. That means that they hit each other at 1, 2. And the other one is 714. And again, that's easy to see because the blue and the red match. Those numbers match. The other thing that I want to show you very quickly is how to solve this by hand. Both equations say y equals. So I can use the substitution method. I'm going to substitute the 2x right there in the y. So now it's going to say 2x equals x squared minus 6x plus 7. To solve a quadratic, you have to have a 0 on one side. So I'm going to subtract the 2x from both sides. And I get 0 equals x squared minus 8x plus 7. Now, to solve a quadratic, there are several methods. One method is to solve by graphing. One method is to solve by factoring. Another method is the quadratic formula. The two that we're going to learn in Algebra 2 are the square root property and completing the square. I'm going to show you factoring really fast. We're going to review this later. But to factor this with the coefficient of 1 on the x squared, I'm looking for two numbers that multiply to give me a positive 7, that add to give me a negative 8. So that's going to be a negative 7 and a negative 1. And then we take both of those and set them equal to 0 and solve. Add the 7, x equals 7. Add the 1, x equals 1. So those are the x's on my 2 points of intersection. So notice that the x equals 7 is here and x equals 1 is here. To finish this up, to find the y values, you have to substitute those back in. I would use the y equals 2x. So if x is 7, 2 times 7 is 14. Y is 14, so that gives me that ordered pair. And if x is 1, we get the 2 that finishes off that solution. So that's how you would work that by hand if factoring would work. Keep in mind, we may have to use quadratic formula later. I'm going to do one more really quick. Actually, I'm going to do 2 more. I want to look at number 4. Number 4 says x squared plus y equals 6x minus 6. and y equals 3x plus 1. So the first equation, I need to get the y by itself, so we're going to subtract the x squared. This is now going to say y equals negative x squared plus 6x minus 6. So I'm going to go back to my graphing calculator, back to y equal. I'm going to clear out the old stuff and put in the new stuff. So I'm going to put in the negative x squared plus 6x minus 6 and 3x plus 1. And I'm going to hit zoom 6, which is the standard window. That's what I call home. Now, looking at this, it's very easy to tell the blue parabola does not hit the red line. They do not hit. We can zoom 3, enter, we can zoom out, and you're still going to see they're never going to hit each other, ever. It doesn't matter how far we extend the parabola out, it is never going to hit the red line. So this is an example of no solution. Let's do one more. Let's do number 5. On number 5, we've got y equals 4x squared plus 6x plus 3 and 6x plus y equals negative 6. And on that second equation, I'm going to subtract that 6x. And it now says negative 6x minus 6. And I'm going to put that into my graph. So back to y equal, clear out this old stuff. And I'm going to put in the 4x squared plus 6x plus 3. And it just occurred to me that on every single one of these that I've done, I put the quadratic in first. And I want you to understand it does not matter which one you put in y1 and which one you put in y2. That does not matter. The second equation, again, was y equals negative 6x minus 6. And I'm going to zoom home, which is number 6. Zoom standard is home. Okay, so looking at this, it might be a one solution kind of situation going on here. It doesn't look like I have two, but we're going to double check. I'm going to hit second trace, number 5. So my cursor is on the right side of this parabola. So it's going to give me the intersecting point closest. So if there's an intersection down here, it's going to give me that point. So I'm going to hit enter, enter, enter. And the intersection, use your common sense here, is negative 1.53. I give you permission to give me decimals here. Negative 1.53. Okay, so there's our answer for that side. Now let's double check. What if there's another intersecting point over here and I just can't see that they're crossing over, that it crosses here? So let's repeat that process. Second trace, number 5. Now what we need to do is arrow to the left. So the first time that we did this, the cursor was on this side. So it's going to give me the intersecting point closest to that. Now I want it to be on the other side of the parabola. And if there's a different intersecting point, it's going to give me that. Enter, enter, enter. And we get negative 1.53. So there's only one solution on number 5. All right, so those are your notes for lesson number 4 on solving systems when you have a linear equation and a quadratic equation.